السلام عليكم ورحمة الله وبركاته. طلاب الفرقة الأولى شعبة الرياضيات باللغة الإنجليزية. إن شاء الله النهاردة هنكون مع شابتر 3 الجزء الخاص بالليميتس. هندرس فيه الكونتينوس فانكشن أو الدوال المتصلة. إحنا بنقول the function f of x is said to be continuous function at point x equal e if and only if the following conditions are satisfied. يعني أنا أقدر أقول إن الفانكشن ال fx دالة متصلة إذا حققت معايا تلات شروط. The third conditions are f of x defined at x equal a. That means f of a exists. Exist means the value not over 0. يبقى القيمة تكون معرفة لما يكون المقام بتاعها أو الدومينيتور بتاعها not equal 0. Second conditions, the limit at x tended to a, f of x exists. Third condition, the value of the first and second conditions are equal. Now, if limit x tends to a, f of x equal f of a, that means that the function f of x is continuous. يعني أنا first condition f of a is exist. Second condition, limit x tends to a f of x exist. The value of the first and the value of the second are equal. We have two cases. If the example given by more than or equal and less than or not equal and equal. What's the condition for continuous function here and also here? Firstly, in more than or less than حالة الأكبر والأصغر معانا يا جماعة f of a equal right limit and equal left limit. f of a equal limit x tends to a positive f of x equal to x tends to a negative f of x. But in not equal and equal functions, the condition will be f of a equal limit x tends to a for f of x. That means that not equal contain more than and less than. More than and less than. Let we have the first example. The first example proves that the function f of x, which is defined by 1 minus x at x more than or equal 1 and negative x at x less than 1, is not continuous. Not continuous means that one of the third conditions not satisfied at x equal 1. Firstly, at x equal 1, we use x equal 1 in this function. At x equal 1, 1 minus x, that's mean 1 minus 1, which is equal 0. Then f of a equal 0, that means that it's defined. The second condition, f of x, we have more than and less than. We use with more than right limit and with less than left limit. Now, the left limit for f of x, that means that limit x tends to 1 for negative x, which is equal negative 1. And the right limit for f of x, it's x tended to 1 for 1 minus x, which is equal to 0. We notice that the value of right limit and the value of left limit not equal. So the limits f of x doesn't exist. The third and the first condition satisfied, the second condition doesn't satisfy. So we can say that the function f of x is not continuous. The second example discuss the continuity for the function f of x squared minus 4 over x minus 2 at x not equal 2 and 1 at x equal 2. We will discuss that at x equal equal 2. Now we should know that we have 3 steps. First, we should find the value f of a, which should be defined, and we will find the limit of function f of x, what it should be exist, and the third condition that the first and second are equal. Now, f of a at e or x equal 2, f of 2 equal 1 from the given, and it exists. Second, we will find the limit at x tends to a for f of x, limit x tends to 2, for the function x squared minus 4 over x minus 2. Remember that we can solve it by using zero factor. Zero factor means that x minus 2, we should know that x minus 2 will be in numerator and denominator. By analysis, x squared minus 4 will equal x minus 2 times x plus 2 over x minus 2. We can cancel x minus 2 with x minus 2. Now we have x plus 2 at x equal 2. It's equal 2 plus 2, which is equal 4. We can notice that the value of f of a is exist and equal 1, and the limit is exist and equal 4. The third condition, what's the mean that the function f of a and the limit f of x not equal 1 and 4. So we can say that the function is not continuous at x equal 2, as the third condition doesn't satisfy. The following example is given by, if the function f of x equal x squared minus 4 over x plus 2 at x not equal 2 is continuous for all real numbers, find the value of f of negative 2. This function we can deal with this form. We should write this form in the standard form for the function. We will study the continuity for it. We can write this function in the form. The function is equal at x not equal 2 was x squared minus 4 over x plus 2, and at x equal negative 2 will be f of negative 2, function of negative 2. So from the given, the function f of x is continuous. So the third conditions are satisfied. We use the third condition. Third condition given by f of a equal limit at x tends to a for f of x. So we can write it in the form f of 2 equal limit x tends to negative 2 for the function x squared minus 4 over x plus 2. We're searching about zero factor. Zero factor here is x plus 2. So using analysis for x squared minus 4, it's given x plus 2 times x minus 2. We can cancel x plus 2 with x plus 2. Now we have x minus 2 at x equal negative 2, negative 2, negative 2 equal negative 4. We can say that f of negative 2 is equal negative 4. The end example, find the value of k such that value of k, the function is defined by x over sine to x at x not equal 0 and k at x equal 0 is continuous. He given me that the function is continuous. Then the first and third and second and third condition are satisfied at x equal 0. Now, from the condition of continuity, f of 0 equal limit x tended to 0 for f of x. F of 0 here is value is k, limit f of x here x over sine 2x. To use the formula of rule that limit sine x over x equal 1. Now we put this x in the denominator of sine 2x. The formula limit x tended to 0, 1 over sine 2x over x, 1, its limit is 1, sine 2x over x is 2. So we can show that the limit gives 1 over 2. Now k, the value of k is 1 over 2. That's all for the function or continuous function. Good luck.